Hi all, let's see the next topic of Unit 2, the design of control unit. The function of a control unit in a computer is for generating the control signals. Uh, it also manages the ALU and other units of a computer, right? So in the design of a control unit, there are two ways of designing a control unit. One is using hardwired control unit and microprogrammed control unit. So in case of a hardwired control unit, the design of a control unit is done using hardware parts such as your multiplexers, decoders, flip-flops, etc. Whereas in case of a microprogrammed control unit, the control unit will be designed using a software program which is called as a microprogram. So a microprogram is nothing but it consists of a set of instructions called micro instructions, where each micro instruction is capable of performing one or more micro operations, right? So if we see the instruction format of a micro instruction, it is of a size 20 bits and we have four fields called micro operation fields F1, F2, F3, condition field for branching, branch field and address field. So it contains four fields. So if you look at this micro operations field, it contains three micro operations F1, F2 and F3, each of size 3 bits. So the control unit is designed using a 3 by 8 decoders, three 3 by 8 decoders where each decoder takes an input of one micro operation field. So F1, F2, F3 are given as an input to a 3 by 8 decoder, and as we know that the size of the particular function is a 3 bit, it will give 2 to the power of 3 possible outputs starting from 0 to 7. We have already seen here like each function it performs 8 micro operations F1, F2, F3. So similarly here the 3 by 8 decoder it takes a 3 bit input and gives 8 bit output. So each function is given to one decoder. So out of these 8, one is a no operation field. So if you look at this table 0, 0, 0 for all the functions F1, F2, F3 that doesn't perform any operation. So it is a no operation field. Whereas in case of F3, the last one, 111, it is reserved for some specific purpose. So the total number of operations that can be performed by a micro operation function F1, F2, F3 are here. We are performing 7 plus 7, 14, 14 plus 6. So totally 20 micro operations will be performed by micro operation field. So out of this 20 micro operations, we are giving, we are in this diagram, we are specifying only 5 micro operations. So if you see this, from here we are taking from F1, we are taking 4 micro operations. From F2, we are taking 1 micro operation. So this diagram will explain you only about 5 micro operations out of 20 micro operations possible by F1 function. We are not showing all the connections for all the micro operations in this diagram because that makes the diagram more complicated with the connections. So they gave a simple example with just 5 micro operations. Similarly, all the micro operations will be performed using the same design. So we'll see one example. So if you look at the F2 function, the three input 3 of the F2. So what is if you look at the F3 function, the three input, what does it perform? Sorry, F2. So it performs an AND operation 0 1 3 1 3 means 0 1 1. It performs an AND operation on the contents of the accumulator and data register. So whenever this input is given to an arithmetic, here we have a unit called arithmetic logic shift unit, which is responsible for performing arithmetic, logical and shift operations. Right. So when this particular input is given, output is given as an input to an arithmetic logic shift unit, it performs an logical operation and on the contents of the accumulator register and the data register, and the result of the particular operation is loaded back to the accumulator. From the ALU, the load function is enabled with the accumulator so that the output is written back into the accumulator. So this is how this operation works. Similarly, if you look at the F1 function for 001, the operation is add. So if you look at the table for 001, it performs add operation on the contents of accumulator and the data register. So whenever this output is given as an input to an ALU, it performs an addition operation on the contents of the accumulator register and the data register, and the result is loaded back into the accumulator. So if you look at the next instruction, if you look at the output 4 of a F1, it is DRTAC. So if you look at the table, 4 means 100, it represents a micro operation DRTAC. So the contents of a data register are moved to the accumulator. So whenever this output is given as an input to an ALU, it performs a transfer operation on the contents of the accumulator and the data register. So whatever contents of the accumulator with the they are loaded into the data register. So that is done. Next is the DRTAR 5 DRTAR. So which means the contents of the data register 0 to 10 bit contents of the data register are moved to the address register. So if you look at this, when this is given as an input, what it does is, so through a load function for the address register using a load input enabled, the contents of the data register are transferred into the address register. So the data register through the multiplexer, the 0 to 10 bits of the data register are transferred to the address register by enabling the load input. Similarly, if you see the 6 output, it is PC to AR, the program counter to address register. So the contents of the program counter are transferred to the address register. So the from PC through the multiplexer, the contents of PC are transferred to the address register by enabling the load input of the address register. So this is how these operations, these micro operations will be performed by you are designing your control unit in such a way that the micro operations are being performed. The outputs of the decoders are connected to ALU so that the ALU performs this particular operations with the help of this diagram. So similarly, here we have explained only 5 micro operations. Similarly, all the 20 micro operations of 3 functions F1, F2, F3 are performed using this design. So each of the output must be connected to a proper circuit to initiate the corresponding micro operation. So when F1 is 101, the next pulse, at the next clock pulse, it transfers the contents of data register to address register. Similarly, if F1 is equal to 110, which means 6, there is a transfer from PC to AR. Similarly, for all the micro operations of this table, the particular control unit, it allows the ALU to perform the operation based on the outputs of the decoders. So this is the design of a control unit. Thank you.